Thank you, Neil, for the introduction. Good evening, everyone. I'm Jian Han. I'm a faculty investigator at Hassan-Alpha Institute, but also a founder of two biotech companies on campus, iCubate and iRepertoire. I joined Hassan-Alpha after we sold our first company and after actually SARS outbreak. SARS changed my life. We had the first company and developing diagnostic for infection for genetic disease, and all of a sudden SARS hit. We quickly turned our technology and focus to develop a 10 pathogen panel, not only detect SARS but other virus bacteria cause SARS-like symptoms. And that got other companies, including CDC's, attention. We did a large clinical study and collaboration with the CDC. We developed a respiratory panel, HPV panel, staph panel, and so the company got acquired by a German company. Then I joined Hassan-Alpha Institute, but every time there's an outbreak, you may remember H1N1, H5N1, H7N9, Zika virus, Ebola, we all joined in and developed assays. The H1N1 outbreak, I still remember, at Diatherics, we developed the assay and run more than 30,000 patients. And when we run the first 10,000, we wrote a paper. We find out when there's an outbreak, only 1/3 of the patients actually have H1N1. Rest has something else. And it wouldn't be nice to diagnose you are not having H1N1 or you are not having COVID, you are having something else. So that is the advantage of our technology called multiplex PCR technology. And that's still being used by Diatherics, still in this building. Last time I checked, they are running average 10,000 samples a day to diagnose COVID. So this time when COVID hit, we quickly joined the fight and we collaborated with international scientists from China, from Japan, from Portugal to sequence the 10 patients of COVID-19 patients. Sequence not their genome, but their what we call immune repertoire. It's their T cell, B cells that generating antibodies. And we sequenced them at the beginning of the onset of the disease, a few days later, and when they recovered. But before that project, last year at Hassan-Alpha at iRepertoire, we studied 7 individuals in our company, injected ourselves with a flu vaccine, regular flu vaccine. And before the vaccine, we already get the blood, and the day 1, day 3, day 7, day 14, day 21, we got the blood again. We sequenced the T cell, B cell, and we identify those T cell, B cells. Around day 7, there's a huge peak generating antibodies. So we know when to look at, how to look at these cells that responding to a viral antigen. We apply those filters to these COVID patients, and we identified a group of B cell antibodies that made by the patients contribute to their recovery. And we made them synthetic B antibodies, grow them in larger quantities so we can do deeper study and study their effect. We actually already got the data showing they are neutralizing antibodies, meaning they can block the entry of virus. This technology already being used at NIH 2 years ago, and it developed a malaria vaccine. So this technology is matured, but and that's why I'm quite confident and optimistic that during the COVID-19, not only us, there are so many scientists with better technologies, better equipped than 10 years ago during the SARS outbreak. So we can come up with a treatment, either vaccine or treatment, very soon in the winter, before the winter. So, but we have a better technology called single cell sequencing that is much quicker to get the antibody from patients. So as soon as the disease come to United States, Alabama. We work with Hassan-Narfa Institute, Dr. Rick Meyer, and we work with Huntsville Hospital. We get very supportive from up and down all the people, from Dr. Jeff Sands, Joe Campbell, and Robert Chappell, especially Dr. Ali Hassan, who's an infectious disease doc, and we worked previously and write publications before. But this time we try to learn from patients' immune system to fight the virus. And the nurse is very helpful. Gretchen Broadway helped us find all these patients and chasing them down, getting their blood every the other few days. And so we got very successful development on the treatment side. On the diagnostic side, we identified over these past 30 years, every time there's an outbreak, we join the fight, but we do something, but it's not good enough. The reason not good enough is we've been developing technologies for healthcare. Actually, it's for sick care. We are taking care of individual patients, but ignore public health altogether. And when COVID outbreak happens, we are surprised by the volume, the tests needed. We have a shortage of all the reagents, even pipette tips. So we developed here in Huntsville a cough DX. Instead of taking the painful swabs, we cough into a cup, and which is pre-treated, preserved the sample, and come to the lab. We only need to add water and directly go to do molecular diagnosis without the complicated extraction step, which is creating the shortage and the blockade and the bottleneck. So we developed these, again work with Huntsville Hospital. We did a clinical study. We did a side-by-side comparison between swab and cough. Not only the cough is easier to collect, easier to transfer, it is also the best sample to get. The reason other people didn't get it is because the swab is being around for hundreds of years. We've been using it to put into a buffer to ship it to the lab, and then we can culture them, to grow them up. But with molecular diagnostic, we no longer need to grow them up. We need a dead genome, and that's what we are getting with this technology. We also have a barcode on each one of the cup, unique barcode. We developed a mobile app, so you scan the barcode, put in your information, and then you get a report back to you, or your employer's HR department get a report, or public health, and for contact tracing, for quarantine enforcement. If you are test negative, you can use this like a passport to go travel, to buy airline tickets. So all that information help processing the sample all the way. And those are already built in the technology from the beginning. So we are going to roll out these very soon. Here in Huntsville will be the world class and help the local community and worldwide to fight this disease. So thank you very much. I hope we'll see you again next year, and without this social distance. And I would like to introduce Dr. Jeff Sands to be the next speaker. Thank you very much.